In this video and in the rest of the videos in this playlist, we will be talking about the most important probability distribution out there, which is the normal probability distribution. It's so important that if you can only take away 2 or 3 things from the course, the normal distribution should be one of them. Now, a variable x, which is normally distributed, has the following probability density function. So the PDF f of x is equal to 1 over sigma x times the square root of 2 pi times e to the negative 1/2 times x minus mu of x divided by sigma of x all square, where we have mu of x being the mean of the variable x, sigma of x is the standard deviation of the variable x, and then x is a normally distributed variable. Now we know that if we plot the PDF, we get the probability density curve, right? So let's go ahead and do that. This is a very complicated function to plot, but if you can plot it, it produces something that looks like this. So this is the probability density curve of a normal variable. Now let's talk about some facts regarding the normal distribution. First off, the area under the curve, so the area under the probability density curve of a normal variable is equal to 1. And the two tails continue forever. Right? This implies that the variable x has no minimum value and no maximum value. Okay. Now the second fact is that the probability density curve of a normally distributed variable is symmetric about the mean. So what that tells us is that everything to the left of the mean looks exactly like everything to the right of the mean. So everything left of the mean mu x is exactly like everything right of the mean mu x. And then the third fact is what is known as the empirical rule. Okay. And this rule says that about 68% of the observations are within one standard deviation of the mean. Okay. Then about 95% of the observations are within two standard deviations of the mean. And then about 99.7% of the observations are within three standard deviations of the mean. Okay. Now, about 99.7% of the observations, that's practically almost all of the observations. Okay. Now, graphically, you have something that looks like this. So if you have the probability density curve, okay, and if this is your mean, if we have one standard deviation here, so this is sigma x, this is sigma x. If you have sigma x here, and then sigma x here, and then another sigma x, right, and then another sigma x, then we have the following. This interval, right, so the interval one standard deviation away from the mean contains about 68% of your observations. The interval, there is two standard deviations from the mean, contains 95% of the observations. And then the interval, there is three standard deviations away from the mean, contains 99.7% or almost all of the observations. Okay. Now note that when we say within a given number of standard deviations away from the mean, we were talking about being both smaller than the mean and greater than the mean, right? So as indicated in this figure. So let's look at an example. So I'm gonna write my example over here. Suppose we have a variable x, which is normally distributed. So x is normal, right? With mean of 440 and the standard deviation of 8. Then we know that about 68% of the observations, or about 68% of the observations are in the interval, or are in the interval mu x minus sigma x and mu x plus sigma x, right? So this is the interval. There is one standard deviation away from the mean. If you plug in the numbers in, this is 440 minus 8, that gives you 432, and then this over here gives you 440 plus 8, that's 448. Okay? So about 68% of the observations are between 432 and 448. Similarly, about 95% of the observations are in the interval there is two standard deviations away from the mean, right? So mu x minus 2 sigma x and mu x plus 2 sigma x. So if you plug the numbers in, this is 440 minus 16, that gives you 424, and then this is 440 plus 16, and that gives you 456. Okay? So 95% of the observations are between 424 and 456. And I'm not going to show you the math here, but you should be able to show that almost all of the observations are in the interval (416) and 464. So almost all of the observations are going to be between 416 and 464. So in this video, we talked about the normal distribution. Right? We talked about the form of the probability density function. Then we saw how the probability density curve looks like. Then we talked about the three facts regarding a normal distribution.